The last thing we're going to look at for this unit is scatter plots, and what we're going to do with them is try to tell if there's a correlation, meaning like a connection in the data, and then also to use that to make predictions, because that's really the most powerful thing about linear equations or equations at all in general, really, is that we don't use them just to show what has happened, but we use them to try and get an understanding of what might happen in the future. And we'll see that here. We'll give an example. Okay, so anyway, we have this table, and it shows the number of absences that students have and then their final grade. And what we want to ask is there a connection between the number of absences and the final grade? Okay, and so what we're going to draw over here is a scatter plot. And scatter plots just show data points, and then they help us organize those data points. So each row here is a data point, right? So this number of absences, 0, and a final grade of 89.2 is going to be a data point on our scatter plot, and so is each row, okay? Before we get started, there's only one last thing, and that is this. The final grade depends on, in this case, or it might, the number of absences. So the number of absences we're going to plug in, that's going to be our x value. That's the independent value, right? That's what we're plugging in. The y is going to be the final grade, and that's going to depend on the number of absences we plug in. So again, here's our y value axis, here's our x-axis, and just remember that the x-axis represents the absences, and the y value represents the grade. And so notice that our scale on each axis reflects what each one stands for. So absences is going from 0 to 9 in this chart. So notice we're going 1, 2, 3, 4, 5, right? We're going by 1 because we only need to go up to 10. We go a little bit farther, but we don't have to go much farther. The final grade, however, obviously you can get 100, so you need to go up to 100. So notice we're counting by 5s here, 5, 10, 15, 20, right? Our scale of our axes takes into account what each axis is showing. Okay, so now that said, let's go and plot our points. So x0, final grade 89.2, and we'll just estimate that. So 0 absences is on the axis. So 0 and then 89.2 would be basically a 90, so that's right there. I'm going to label this one, but I'm not going to do that for everyone. I just want you to see how that row corresponds to a point on the scatter plot. Okay, now we have 186.4, so I'm going over to 1 and then up to 86.4, which is still pretty high up there. 2, 83.5, so I'm going over to 2, going up to 83.5. 3, 81.1, so going up to 3, 81.1, which is right here, going up to 4, 78.2, and that would be like right here maybe. 5, 73.9, so 5, 73.9, something like that. 6, 64.3, so 6, 64.3, just below 65. 7, 71.8, so 7 is right here. 71.8, just over that. And 8, 65.5, 8, 65.5 would be right here. And then 9, 66.2, so 9, 66.2, and that's right here. Okay, so we plotted all of our points, and one of the things that we want to point out right away is that notice it's not a perfect line, right? The data in general, it kind of goes this way, right? But there's not a perfect line. And the reason this is important is because in real life, there generally isn't a perfect line. We generally have certain things where there's clearly a relationship. And in this case, we can see there is some sort of connection between the number of absences and the final grade. As the number of absences goes up, right? As that goes up, your final grade goes down. There's definitely a correlation or connection between them. But it's not exactly perfect. It doesn't mean if you have 2 absences, you're going to get exactly an 83.5, or every student's going to get exactly an 83.5. And so that's one of the important things when we use this idea of linear equations for real life purposes, is that we're often not going to get that perfect line, but there's still a connection in the data. And that connection we call correlation. And again, that just means, is there a relationship between what's happening to the X and what's happening to the Y? So let's look at the degrees of correlation. So first of all, you can see all these dots over here, all over the place. There's no connection. There's no relationship between X and Y. There's no pattern, right? When we say a relationship, what we're looking for is a pattern. Here you can see these are sort of, this line is, there's sort of a connection. They're kind of going up to the right, but it's still not like a perfect line. So we could say there's a low degree of correlation. Here, these are really tightly packed, and that line's pretty tight, right? And so there's a high degree of correlation. And then here you have a perfect line, and so that's perfect correlation. Now, what we're going to focus on more in this lesson is just the types of correlation. Positive, and you can see that has a positive slope, that line. That means as X goes up, Y is also going up, right? As X is getting bigger, as we're going to the right, Y is also going bigger, we're going up. That's a positive correlation. Negative correlation has a negative slope, right? You guys are familiar with negative and positive slopes. So negative correlation, negative slope. It's really simple. In this case, as our X value is getting bigger, our Y value is actually coming down, okay? And then here, there's really no, this curve correlation. We're not going to worry about that. We're not going to worry about that. The big ones we need to worry about today are this: a positive and negative correlation, and then if there's no correlation, right? If you just have sort of this mass of data points all over and there's no clear pattern, there's no line that's forming, we'll call that no correlation. The last thing we're going to focus on is this, and this is the most important thing. We use scatter plots not just to show what has happened, but because they help us make predictions in the future. And so we could ask this question: what grade would you expect a student with 15 absences to get? So notice our chart didn't go to 15, right? So you could say, well, I don't know because I don't have the chart. But once we plot it on the scatter plot, we can see that there's this pattern. And that pattern can kind of extend. So I could just take this line and I could just keep going, right? And again, it's not perfect. I'm just trying to do my best to stay in line there. And now I'm gonna go over to X is 15 because they're asking me 15 absences. I'm just gonna go up, find my line, and it's right about here. Again, that's not perfect, but I could kind of use that as an estimate. And then, so what grade does that match up with? I'm just gonna go over to the Y-axis from my point, and right there, that's a 35. So probably about a 35. So you don't wanna get 15 absences is the takeaway there. So again, we took X and Y values, we plotted them as points on our scatter plot, and there's two things we're doing with that. We're asking ourselves, is there a correlation or relationship between the data? And we're going to say there's no correlation, there's a positive correlation, or there's a negative correlation. And positive and negative, just think slope. Finally, we can extend that line if there is one. Remember, the none, there is no line. But if there's a correlation, we can extend that line and use it to make predictions about what might happen in the future. All right, just quick recap on those two main ideas. So look at each scatter plot. Is there correlation between the data? If so, is it positive or negative? In this first one, you can see these dots are all over the place. There's no clear line that I could draw that kind of represents the data flow. So this would just be no correlation in this graph, in this scatter plot, okay? In the next one on the right, you can see that it's not perfect, right? There's not one line. I can't draw a line that's gonna go through every point. But if I draw this line right through them, that does pretty much capture the flow of the data. And so there is a correlation, and that slope is negative because as our X values are getting bigger, look, we went from 4,000 to 8,000, and our Y values were actually going down as that happened, right? We were going down as our X values are getting bigger. So that is a negative correlation. So there is a relationship. You can tell there is because there's a nice line that fits the data, and that slope is negative, so there's a negative correlation. All right, this will help you a little more with that negative versus positive correlation. Okay. The scatter plot tracks a store's ice cream sales and the temperature outside for 12 days, right? So each point shows the temperature of that day, and this is in Celsius, right? But this is about 11 degrees Celsius, and it shows they made maybe $190 that day. And each point represents one day, right? What was the temperature? How much ice cream did you sell? Okay? First question, is there a correlation between ice cream sales and temperature? Yeah, you can see right here, there's a pretty decent line that would go right through that data. Again, not all the points are exactly on it, but they're pretty darn close. And so yes, you'd say there's a positive correlation because that slope is positive. Okay, so what does the positive correlation mean? Remember, again, this means as x goes up, y goes up. It means they're moving in the same direction. And think about what that means in this case. It means as temperature goes up, switch pen color here. It means as temp goes up, sales of ice cream go up. And that makes sense because you think as the summer comes and the temperatures go up, people go and they buy more ice cream. So when you think about positive and negative correlations, just think, are they moving in the same direction or are they moving against each other? So ice cream, temperatures rising, people buying more ice cream. What about like snow shovels though? As the temperatures are going up, people are buying fewer snow shovels because you're not going to get any snow. So that would be a negative correlation. They're moving in opposite directions. Finally, make a prediction. The next time it is 18 degrees Celsius outside, remember 18 is right there. How much ice cream should the store expect to sell? Well, we'll just go up from there. It's right around here. Now, again, this is not exact, right? But maybe that's like $380. And if you did $375, something like that, that's totally fine. Remember, this is not exact, okay? But the key here is that you can prepare, right? If you're that store and you see a heat wave coming, you can get prepared and have more ice cream available. If you see that the temperature is going to dip, you could call your supplier and say, hey, we're not going to need as much ice cream this time because we're probably not going to sell as much because the temperature is going to go down, okay? So scatter plots help us organize data. The first thing is there a connection? And to answer that question, you're looking for a line. Can you make a line that fits the data? Then, is that connection positive or negative? Just look at the slope. And that helps you understand if things are moving together or apart. And then finally, how do you make a prediction? Well, once you get that line, just find, what they give you and match it up with the other axis, and you can kind of predict what's going to happen in the future.